Hello, today we will continue talking about abstract data types and we'll share the little example of creating our own implementation, maybe so naive, maybe not so powerful and effective, we'll compare it later by performance, of simple unidirectional linked list. It would be our implementation of so-called pure functional data structures. It would be keep immutability and persistence as we discussed on the previous mail. So let's go deeper to the implementation. First of all, we implement a constant called tnil. I'll add a t minus prefix to all my custom functions just to show the analogy to the existed ones and just to split them and not to mask. So the tnil would be any value actually. In Clojure it's actually nil. I choose 42 because, as you know, it's a common answer for the most common questions in the world, yeah. And at the same time I'll immediately add a predicate just to check if our list t is nil, if it's empty, just by comparing its value with with 42, with tnil value, because it's constant. Just immediately want to say that we would not implement so-called dotted pairs like they are in scheme language. It's very similar and very close to the list, and actually my implementation is also appropriate for so-called dotted pairs, but we will use it for regular list implementations and forget for a while for dotted pairs who know what I'm talking about. So let's focus on regular lists. So then we have to implement three interface functions: the constructor of list and two getters, a getter of head and getter of tail. The constructor would be implemented as lambda encoded lists. It's well-known approach for the lambda application, how to encode lists in lambda functions. Here is the right example. It's a function which will get some special service function which either get our first value of input or second one. And then car and CDR, actually, who didn't know what's it, car it means head and CDR it means tail or rest or next. It can be named by different name in different languages, but it's actually a head and a tail of the list. And then head of the list would be actually so our list is actually the type underline is a function, so we can call it. We will call the function list on some service function internal, and for getting CDR we will call our t as function on another internal function which returns actually its second argument. Then we have to create some libraries specific list functions just to construct some lists, just to operate with them, just to make some processing of it, and finally showing. First of all, tmap, it's an analog of a regular map, a function on list t. If it's our tnil is right, then we'll return tnil, else the tcons, blah blah blah. So regular naive implementation of tmap, and only one thing I have to put your attention on is that this implementation of map, it's not very effective, because in a case of big long list it fails with Stack Overflow. In languages which have not any guards for Stack Overflow. For example, in Haskell it will work for any list, yeah, because it's lazy and it's not so easy to break the Haskell by Stack Overflow. But here in Java it will break by Stack Overflow because it's not tail call recursion. In order to implement map as a tail call function, we may either reverse list and reverse them again or before returning value, or make this list lazy, and lazy data structures we'll analyze in the next nail. But here I'll show you the just raw primitive examples how we can implement pure functional data structures if they are not yet in this language for some reason yet. Then T-filter, by the same way, not tail recursive, maybe Stack Overflow. And then T-reduce, so a folding function is actually strict left reduce in terms of Haskell, yeah. But as opposite to the previous two, the reduce is a tail recursive function. I can use a regular recur. Yeah, but all other implementation details are very straightforward and very primitive and similar and common. Yes, the last two functions I should implement to show you some cases is to tshow, so-called. I have to represent my data type in a string value in a REPL somehow, just to show how it will look. For example, if I implement some special data type, then I have to create a visual representation of it, at least, just to show you. So I'll add vertical lines to the both left and right side of the href list. Yep, and also I implement tRange, function tRange, which takes A and B, and so it's just analog of a regular range on regular list, and it's also tail recursive. So let's play a little bit. First of all, I'll show you how it will show just raw range. Yep, tRange from 1 to 10, 1, 2, 3, 4, up to 9. Yep, 10 is exclusive. Let's filter even values from it. Yeah, 2, 4, 6, 8. Yeah, okay. Then we can map it after filtering or without it. Map multiplying by 10 each value. Yes, 20, 40, 60. Everything's work. So here you see that our bare bonus regular unidirectional list functional data type is implemented, and we can use it in any our algorithms. We can substitute this implementation of the regular list in Clojure, and in a case of finite strict lists, they will work the same. For example, let me show how it reduces by taking some amount of the list. Yeah, sum is 200. And here actually two calls for compare the performance. I create two lists, about 1 million elements, range from 1 up to 1 million here and there. The only difference is this range is lazy, but this range will expand into my memory directly, because it's strict. It's not a lazy sequence. Yep, so let's go. Time. So the time comparison, it's about maybe less than 2 times. By different calls, it depends on computer sections and so on and so forth. But it's not a very critical difference between already built-in list implementations. For example, on these cases, I definitely excluded from here any map and filter calls, because on a strict list of million they will fail by Stack Overflow. For example, I can show you it here. For example, for 1000 values it works, but for 10,000 values it fails by Stack Overflow, because I apply filter map, but when I comment it, it will works. But then again, I can show it's not a critical case that we cannot avoid Stack Overflow on function map or filter. We can we can make them tail recursive, and avoid Stack Overflow by using 2 times revision as a result, yeah, for example. And it's not a critical case, but the main thing I want to show you on this nail is that even if we do not have such type of very usable, very convenient pure functional data structures in our language, for example in Python, in JavaScript, in any in any other languages, we can implement it just as several lines of code, like I described and explained you just right now, and having it in a case of our language such as library implemented data type, actually abstract data type, which hides a linked list abstraction. So please enjoy, use it in your preferred languages if you prefer Python, JS, or something like that. Yes, so, and see you on next nail, where we will be involved in implementation of lazy infinite pure functional data structures. See you.